Assalamu alaikum. My name is Sushma Karmakar. Today I will talk about one-time pet algorithm. So let's get started. At first we have some introduction about one-time pet algorithm. So the explanation is the one-time pet algorithm is a symmetric key encryption method where each bit of plain text is XORed with a corresponding bit from a truly random key of the same length, providing perfect secrecy when the key is used only once. It is a secure but requires a key as long as the message and is vulnerable if the key is reused. Why one-time pad algorithm needed? The one-time pad algorithm is needed for situation requiring absolute secrecy as it provides perfect encryption when the key is used only once. And we have also the real life example. A real life example of one-time pet algorithm is espionage communication where spies may use pre-shared pairs with random key sequences to encrypt their messages. Each pet is used only once, ensuring the highest level of secrecy, but logistical challenges and the need for secure key distribution make it impractical for most everyday encryption scenarios. Let's move on to the next page. Here, I will discuss about the one-time pet algorithm mathematical term. So, here I consider plain text as my name is Sushmoy, and here the key is also in string, and the key is I will shine. After that, we will get the ciphertext value like this. So how can we get the ciphertext value? We will see that now. So at first we have P. P means plain text here. So I write all my character M, Y, N, A, M, E and so on like this. Then we have PI. PI means the number of alphabet. So I consider A as 1, B as 2, C as 3 and so on. So here the M equal 13, Y equal 25, N equal 14, A equal 1, M equal 13 like this. Then we have the key value. Mm, let's see here in plain text I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 character. And in my key I have only 1, 2, 3, 4, 5 and 5, 10 characters. So 4 character is short. If we get this type of things, so we need to consider as a key. First of all, you will write the whole key, how many you have, like I, W, I, double L, S, H, I, N, E. Here my key is finished. So we'll start again from the front like this. I, W, I, L, I, W, I, L like this. If I have more to go, then I will consider as this L, then S, this S, like this. Then we need also the number of alphabet of this key value, like I equal I means 9, number of W means 23, then again I means 9, L means 22 and like this I consider. So um, for plain text to ciphertext we called it as encryption. So for encryption we need to do CI, find out CI. So how can we find out? Here you can see the logic. Ci equal to pi plus ki. That means pi plus ki. We need to sum of pi plus ki. So 13 plus 19 equal to 22. So I write this here. Then 25 plus 23, 48. I write this here. Then 14 plus 9 equal to 23. I write this here. 1 plus 12, 13. I write this here. 13 plus 12, 25. I write this here. So all of for all of this I write all of like this. I write like this. Then where the number of CI is between 1 to 26, that's are okay. We just simply write in the another CI text 22 as 22, 23 as 23, 13 as 13. But you can see in second line why the CI value is 48. But 40 is we have in 40 number 48 we don't have any alphabet. We need to find out the value of 1 to 26. Then we have another 28, 33, 28, 36, and 37. So how can we do this? For this, here you can see the logic. If CI is greater than 26, that means this CI value is greater than 76. So 48 is greater than 26. So the condition will be true. Then we need to do the new CI. New CI means CI modulus 26. That means we need to find out the modulus of this 48 modulus 26. Suppose if I divided 48 divided by 26, we will get the 22. Then if I divide 28 by 26, we will get the modulus of 2. Like this, we will get the value. Then after getting the value, then you can see all the value are in between 1 to 26. So here 22 means B, 22 means B, 23 means W, 13 means M, 25 means Y, 24 means X, 17 means Q. So we get the ciphertext and encryption is done here. Let's move on to the next page. So here we need to do decryption. What is decryption? Uh, uh, in encryption we get the ciphertext. So here we will work with the ciphertext and we will get the plain text back. So how can we do that? Let's see. First of all, we have C. C means ciphertext. I write all of ciphertext here like this. Then CI. CI means the number of alphabet of ciphertext. Then the key is always same. Then key is same. I will shine. Then I write I will shine. The four length is short here. Then I will consider as in front IWIL. Then we have the PI. So for finding the PI, what we need to do here? The logic is if PI equal CI minus KI, PI equals CI minus KI, then we will get the PI value. Then 22 minus 9, we get 13. 22 minus 23, we get minus 1. 23 minus 9, we get 14. 13 minus 12, we get 1. 25 minus 12, we get 13, and so on. Like this, we get the value. But here we can see some minus value are invented here, like minus 1, then we have minus 7, minus 7, minus 7, minus 13. And lastly, we have minus 1. So we don't have any negative value alphabet in our list. We need to find out the value 1 between 1 to 26, value between 1 to 26. So how can we do it? Here you can see the logic. If pi is less than 1, that means the pi value is negative. We need to do, actually it's need to do the other encryption, only do pi modulus 26. But how can we do this modulus? I will explain it here. First of all, we write y equal mat.cell abs pi divided by 26. What does it mean? First of all, you need to take the value 1. That means the pi value, it is you need to get why I write abs here. We need absolute value, that means the positive value. After that, we'll divide it this one as divided into 26. Then we'll get the value. We get some 0 point something, but we need to need the upper value. That's why I write mat.cell. It takes the floating upper value. So here I will get 1. Then you need to divide what value we find in y. Now we divide 1 into 26. You will get the 26 value. Now you will get the new pi. New pi what? You get the y1 value and pi. Pi value was what in first? Minus 1 plus 26. We will get 25. Let's see. Yes, we can see here the value is 25 like this. So after all of this, I write like this. If you calculate minus 7 value, then you will get the 19. All of this here. Then I write of my all of my plain text value here 13 am 25y, and let's you can see that we'll get the value. My name is Sushma as it. So our decryption is done here. So let's move on to the code. Here I take a screenshot the code, and I will write this code as Python with Python. So you can see the code here. I can go I be here one time pad code. Now I'll explain the code to you. First of all, you can see the plain. Plain means I take a variable and get the input. Enter the plain text. I want a plain text here. Dot why I write dot here? Because in this code I work as the lowercase letter. So if I write input in uppercase letter, it will convert into lowercase letter. It's easy for us. Then we have the key. We want a key from user. Like here, the plain means my name is Sushma, and the key is I will shine. Then we have encrypted text. What we need, it is here, and the new key. Then we call it function as a encrypt. We'll talk about here in this function. So I write plain and key. I send you to the plain key and plain text and key here. So in encryption, we will get the plain text and key here. First of all, result is done. I will write with what I will get. I will write row convert into result. But first of all, we didn't do anything. The result is none. So what we need to check first? I write if len key is len. That means key is smaller than plain text. We need to modify this. We need to modify this? As you can see in algorithm, the key was I will shine. It is lower than lower 4 length. So I write this part is right in this code. So then lel I'll take it as a random variable. Then I minus len plain is minus len key. That means we will get the how many length we have short. Then we will get the new key here. New key. That means I will shine. Then added for IWIL key. It means in Python key plus key. It means 0 to length. Which length? Like in my algorithm, the 4 length was short. It is get 0 to 4 length and added to the new key, and we will work as a new key. Else, if the key is not smaller than length, then it is only will running with key with the plain text only. That means always plain key and sorry, always plain text and key will be same. So let's then we have for loop for I in range plain length. For loop will running the length of plane. Then I will consider plane as a character. Then we write pi value word a character minus 96. So why we do that? We need to find we know in lowercase a, the ASCII value is 96. 90, sorry, 96, no, 97. So for getting, but I consider a as 1. For getting the value of 1, I did this word CSAR means we get the ASCII value. If I write minus 96, then we will get the one value. Like we will get a here. So the value of the ASCII value of a is 97, and 97 minus 96 we will get 1. Like this. If we get b, 98 minus 96 we'll get 2, like this. Then as if for the key will also the way is same, or the new key minus 96 we'll get the ASCII value as with a 1 2 3 4. Then what was our loss? Ci equal to pi plus ki. We will wrote this we seen in algorithm. After that, if we saw ci value is greater than 26, we need to do this new ci equal to ci modulus 26. After that we will get the value. Then which value we get will convert into the result. Here you can see result plus equal character new plus 96. And why we plus this 96? Here we get only the ASCII value, but up in result we don't need the ASCII value, we need the exact value like A, B, C, D like this. So I plus 96, then it will convert into 97 if it's small a, and if it is small b, it will get to the 98 and we will get the result. So we return the result and new key. It is came into the encrypted text and new key. So encrypt part is finished here. After that we have the decrypt part. So in decrypt part we need what? Encrypted text and the new key. Encrypted text and the new key. So we get the new key here. So let's move on to the decrypt function. Here you can see the OTP here, the decrypted function and key, the new key what was again. Then we have same as this result is null. Didn't do anything. Then OTP means share ciphertext. I just write the OTP. So for loop will running the ciphertext or OTP length. Then as all are same, CI minus in encryption it was Ci plus Ki, but here it is Ci minus Ki, all of them. And here, if Pi is less than 1, we have the problem. As we discussed in algorithm, we need to do this mat.sale ABS. ABS means absolute value, always positive value. We need to modulus with subhash, and then what we get, if we get 0 point something, we need to consider it 1, or we get 1 point something, we need to consider as 2. Then we need to uh, subtract the, we need to multiply the value of y with 26, then we will get new pi equal to pi plus 1. After that we also here we write the 96 value for getting the exactly uh, result like A, B, C, D like this. Then we will only return the result. After return the result, we will get the decrypted text. Here we print the encrypted text. We will get the encrypted text, then print decrypted text. So right now I will run this code, and as you can see, enter the plain text. My plain text was my name is Susmoy. Then what was my key? I will shine. As you've seen that my encrypted text was this and my decrypted text was my name is Sushma. That means in after encrypted we will get the same value as plain text. That's all about the code. You can see. Then let's move on to the slide. Here you can find the code, the value, the output, and the discussion about this. That's all for me. Thanks for watching.